Hi, I'm Dave, and I'm going to talk about Event is the New Model. So you can find me at davidmfoley on pretty much all the things if you want to follow up. Tell me how stupid my talk was. I work at Substantial. I'm the CTO there. That means I'm a frustrated ex-programmer. So I like to get up here and talk about things I don't know much about. We're a digital product studio based in Seattle. We also have offices in San Francisco and New York. If you want to hear more about that, just talk to me after. So before we really get started, I've got one small request, and it may actually be a really difficult request for anyone to fulfill given the Wi-Fi situation. But I'd like you to help me with the maiden voyage of a piece of software that we built at Substantial in the last week and a half. As this is the first time this song has ever been performed live, and I'd like you all to be a part of it. So yeah, go to prezzorator.com on your phone, enter that code, and that code will stay on the bottom of the screen throughout. And then it'll become more obvious what this funny undulating blue line is at the bottom of the screen. Yeah, it's actually here on the bottom of the screen throughout, but I'll give everyone a chance to take a look. Hey, I'm doing great so far. Thanks, guys. I swear I didn't do that voting. You saw me up here, and my hands did not move. So yeah, we'll talk a little bit more about prezzorator in a minute, but thanks. So another quick announcement, and this might drive the approval rate in the opposite direction. My code examples are going to be in CoffeeScript. CoffeeScript, if you haven't heard of it, it's a lot like JavaScript, but less shitty. It probably is going to make you angry, and that means you're paying attention. Okay. So I want to talk a little bit about what I call snapshots and what you probably call models in a model view controller type of application architecture. So many, if not most, applications that we build, and I'm talking about like database-backed applications, store their data and application state in terms of a point-in-time snapshot. So you might update tables in a database, and you can always go get those tables, select something, you can find out what the state of the world is at any given time. So the M in MVC is the easy way to think about this. And this is popular because it's really convenient for a while. The problem is that point-in-time models beget projections. And when I say projection, I mean things like views in an SQL database, stored procedures, or like really long mapping code that loads up 50 things from the database, smashes it all together into some crazy JSON format, and then spits it out. These things are necessary in order to be able to look at the data in the way that we want to see it. And the problem with these sorts of projections is that they make the underlying data model harder to change. And so projections beget more projections, which make that underlying data model also more difficult to change. And that's how you come into the brownfield world of software development. So I'm proposing that we default to storing events, not snapshots. So an event, when I'm talking about event, what I'm talking about, you might hear other people call an application event or a domain event or something of that nature. That's great. I don't really care what you call it. But what it is a discrete package of one state change in the life of an application. We want it to be as meaningful as possible. So we want to prefer, rather than update that takes some random hash with 58 different elements, we want to do something more specific. And once an event exists in the world, it can never be deleted. So our world exists as an append-only stream of immutable events. Lots of people have talked about this in kind of an enterprise context, and that's really awesome. I'm not going to talk about that. So I just wouldn't be qualified to. Other people. There are some great talks. Greg Young has some great talks about it, and also, Martin Fowler on his Blicky has a good description. He calls it event sourcing, and that'd be really good to read. So what I want to talk about is events in the small. And I'm really more interested in, with the work that we do, how we can use innovative ways of architecting our applications in order to deliver better software to our clients. And that means evolutionary design, being able to build models that fit their usage, and also something that we get for free in an event-based application, given all the awesome tools we have like Socket.io, which is real-time collaboration. And that can actually be really difficult in a snapshot-based application. So what this makes me think of is the Steve Miller Band. Time keeps on slipping into the future. Now, if you really think about that, time actually slips into the past. So it's possible that Steve Miller actually perceives time in reverse, which would kind of explain a lot. This doesn't actually have anything to do with the talk. Okay, so Preserator. You're using it right now. Thank you very much. I'm really glad that some people are using it. You can't see it right now because the Preserator still image is covering it up. But let's talk a little bit about how it works, because it's a very, very simple example of the type of application that I'm talking about here. So I got the idea for Preserator during the US presidential debates. It's basically this. And I wanted this for presentations, my own, but also to kind of talk shit about other people, So there you go. It looks like the Wi-Fi's down, or you guys are really even. So Preserator, attendees vote on the presentation with their mobile device, up or down, as you guys know. And approval is graphed in real time with science. This is actually a lot harder problem than I thought. I was like, we'll just throw votes in there and then graph something. It's like, no, calculating a moving average that actually makes sense is non-trivial. Probably some of you that know math could help me. I'm not sure. I'm just a CTO. So when you click these things, it's very simple, right? Socket here is a socket.io object, and it sends a vote. This is CoffeeScript. This is why I hid this part of the... So it's got a value of 1 or 0, right? Couldn't be any simpler. So in these kinds of applications, this is how clients ask the world that they want to, or tell the world they want to change it. So then what happens? On the server, a message is received from a client, and there's some data we need in order to process that message. So we collect that, authorize, validate everything. And then in response, we publish out into the world 1 or more events. So let's talk about what publishing means. Means we send it to whatever data store we use. Who cares what it is? This uses MongoDB because I don't care if the data is still there when I come back to it. But you can use anything. You could use a file. It would be fine. Redis or something better. Broadcast to any connected clients. There's just one connected client here, and that's that graph. That's Wi-Fi's fucking up again. And then update any server-side snapshots that we might keep around, which we would use to help us do the other things, the validation. And we can talk about that more in a minute. So here's some more CoffeeScript. And what we do here, so this is on the server. We get a vote in, and this is somewhat pseudocode, but we get some context, right? So every socket is a stateful connection. It stores some session information, just like an HTTP session, except it's like stored in Redis or something. And we get from there which presentation. So presentation is the namespace in this case. There is only one presentation in the world, I know for a fact right now, but theoretically there could be hundreds or thousands of people presenting right now getting voted up and down, or not at all because of the Wi-Fi. And so we've got that information. If the vote is valid, right, we check, is it a valid vote? Whatever that means, we'll build some data, append it to the history, and broadcast it, right? So those are the things we just talked about. So client subscribe. Receive events in near real time, and then update their state of the world and show it to you, right? Pretty simple. So if you take out all the hard parts and the science, this basically looks like something like this. We get a vote in, give it to our model, then once per second, tell the model to update, which, this is a time-based thing, so the model's going to reap old votes and calculate the science, and then render the graph. So that's pretty cool, but this is pretty ugly. So what we've got here is a lot of boilerplate code that's going to make it more difficult to add other events. So as I've built a couple of these types of systems, they've kind of all coalesced around a similar pattern, and I want to talk about that pattern because I think it makes them pretty easy to build. And what I'm hoping is after this presentation, I can talk to some of you, and you will make it better. So kind of the idea here is, if anyone's used Express, I assume a few people here have, make a sort of Express-like interface for handling these sorts of messages. As easy as possible to add and change the business logic of your application, which is in handling those messages, validating them, publishing messages. So the idea is that you extract that business logic into a filter. So in this case, it's the simplest thing possible. God, I get a lot of sibilance when I turn this way. It's the simplest thing possible. Just echo a vote that comes in. Don't do any validation or anything. And that's that filter's hash there. And then to extract all of the kind of yak shaving into a request and a response. So you can just treat it similar to what you would do with Express. So request has everything you need to make your decision, and response is where you publish or send an error or something like that. So yeah, once a filter publishes an event, it's forever, right? It's like the New York Times. It's printed somewhere. You're not going to read it all because it's too big. No. So filters are the gatekeepers. In this case, we only want to publish votes for active presentations with the value between 0 and 1. So that means we want to check that stuff out and only publish in that case. So what I've kind of come to in filters, if anyone's heard of the reactor pattern, there's some pretty interesting writing on kind of similar ideas to this, but I want to keep all I/O out of filters, pass in all the state that we need, keep them very focused on solving a business problem, and that also makes them very easy to test. All right, so more examples. Enough talky talk. So this is another kind of event-focused system that we've built. This is Bluescape, and it's a real-time distributed collaboration tool. Infinite whiteboard is probably the shortest phrase that will evoke something close to what it does. This is Bluescape in action at a furniture convention this year in Chicago. How many of you have been to a furniture convention? For real? You from Michigan?
No.
So me and you win. We're the winners of furniture conventions. Anyway, yeah, that's the case. So Node.js server using WebSockets, thousands of clients, et cetera, big numbers, blah, blah, blah. Interesting part of this, both pen and touch input. These screens are infrared screens that use reflected IR and generated IR from pens. And that's sampled at 100 hertz. So we have a lot of events coming in. So 100 events per pen or touch per second. And multiple people could be drawing at the same time, right? And you saw what we call the wall there, the wall client. We call that because it's a wall. There's also an iOS client and a web client. And that's the Bluescape team actually using Bluescape to plan their work on Bluescape. So that's kind of meta. I like it. Web client, DOM elements. So a similar rendering of, the same sorts of events, but obviously a completely different rendering strategy that uses canvas and DOM elements. This is a man in a neoprene suit which covers his entire body, including his face, demoing a chair. You know what I'm talking about. All right, I'm going to talk about one more app that we've built in a similar style to this, just because it really touches on what Joe was talking about with the shared code between client and server. This is a tool that we use to run our business. We have, like I said, 60 employees, about 40. Some of those are generally working on products and projects, and it's very complex figuring out who works on what between the 7 to 11 projects we have going at any given time. So we use it for that. So this does use a shared model between the client and server. which, as Joe was saying, is possible. We actually use so we actually use Stitch, which is like the redheaded stepchild of client-side dependency management, but I think it's really awesome. Or I don't know, it works anyway, and I don't really care. But what's really nice about the kind of sharing client-side and server-side code, in my opinion, is that running tests in a browser is awful, and running tests in Node is really, really fast and easy. And it's really nice to be able to only test the things in the browser that require a browser and test everything else in Node. So that's a huge, huge win. It is also easy to break things that aren't exactly compatible between client and server. Events are one thing that aren't exactly the same. And I think that's probably why people think Browserify is good, because they don't have that problem. So yeah, easy to break things. Here's just a quick example of testing a model. You apply some events, and you see that the model's changed. Is the Wi-Fi down, or did my code crash? That'll be fun to find out. All right. So cheat sheet. All the stuff I've talked about, it's pretty fast because I have like 89 slides, and there's like 3 minutes left. But client send messages to the server. Server routes these messages to a filter, also giving extrinsic state that is needed to process the messages. Filter publishes the events. Those go to the world, everyone, and to subscribed clients. All right. So everything sounds awesome when someone's standing on stage blathering about it, but the real world is not awesome. And so what are the hard parts? And these are the things that I want to get some input on. The shitload barrier. When the event count exceeds 1 shitload. Up here, it's like a metric shitload. It's like 2 shitloads plus 30. It's crazy. So fetching that entire event history, right? So if we're truly basing our entire application state on a set of events, the most naive and easy way to do that is to just grab every event in the world and history down to the client, replay it all, and then you have your current state. Well, that eventually takes time. How eventually is the question, right? It really takes a long time on mobile browsers. So fetch performance, on Bluescape, we lean on HTTP. So, use regular caching. It can be cached at both reverse proxy and at the client. And the way that works is we serve up one kind of index, a menu of sorts. Here are all the pieces of history that you can get, and then you just issue gets or serve them out, get them out of cache. So that's one approach. Bookmarked fetching of history. So if I've got the first 10 events, or if I've got all of the events up to 5 minutes ago, I can send that bookmark of 5 minutes ago and get back just the events since then. So that's something else that we've done. Selective replay. So when we're dealing with playing back 100,000 events, that's going to take a long time if you're hitting, like, say, Canvas. So what we do on Bluescape in that case is use an R tree to only play back events which are close geospatially to the screen that or the viewport that we're dealing with. So these are just kind of, some strategies for dealing with the performance side of it. Event schema changes. So I've got an event, and it does something, and I want to either update the schema of that event or change it so that some other event replaces it. This is hard, right? Especially if you have clients that are live. So your choices are basically handle the new and the old, or migrate the old to the new, which kind of screws the whole immutability aspect of this. So yeah, that's a challenge. Event order. Do we care? Usually not. So in Bluescape, if 2 people draw over the same exact pixel at the same time and it shows up red on one and blue on the other, do we care? No. Sometimes you do. Say a CRM where someone's making changes or trying to comment on something that someone else has tried to basically close out, delete. That'd be a contrived example. And in that case, basically, I think the solution is to be mindful and solve these problems as they come up, kind of in a way that suits your application domain, which is like the most equivocal thing I could possibly say. Okay, so what's next? Come talk to me. Let's talk about what's awful about this. And if you're working on something similar, like, let's talk about it and collaborate, because I would love to get some feedback or thoughts. Open source frameworks, is there something out there? I don't know. I've built a lot of applications like in this style, and particularly using Node as a backend. Are there patterns? Is there something else we could bolt on to? Thanks. Wow.